Alright, so in this video we're going to find we're going to work with some second order partial derivatives. So first of all, this remember means the partial derivative of f with respect to x, meaning we treat y as a constant. So I'm just going to leave the y squared up front. Oh, not equal. And it's equal to, or multiplied by 15x squared. So we've got 15x squared y squared, and that is our derivative with respect to x. Partial with respect to y, so now we treat x as the constant. Derivative is 2y, so we have 10x cubed y. Now, computing the partial derivatives. I think these top two are probably pretty simple because what you see is that we first of all are going to find the derivative with respect to x, which we already did. It was 15x squared y squared, and then we're going to do it again. So we're going to find the second derivative with respect to x. So now it's 30x y squared. Okay, so we did the same thing again. We treated y as a constant and found the derivative with respect to x again. And similar to what we're going to do here, we found the derivative with respect to y. It was 10x cubed y. Now we're going to find the derivative again with respect to y. So I'll put this delta y. Well, treating y as, x as a constant, this is just going to be 10x cubed. Those two are pretty easy because you don't have to worry about the order. Now, here's what's a little bit strange. You see here, this xy, this is the order you will be going in. You're going to do it with respect to x, and then take that derivative with respect to y. Here you'll do the derivative with y, then you'll do with respect to x. But if you were doing this with Leibniz notation, how you would write this is you would say, well, first I'm finding the derivative of f with respect to x, and then I'm taking that and I'm doing the derivative with respect to y. Okay, and that looks a little weird because now this looks like the opposite order, right? This looks like you're taking the second derivative of f and you've got that. And here you'd be taking the derivative of y, of f with respect to y, and then of that you'd take the derivative with respect to x. So this would be the second derivative of f, and then x, and then y. But you see how that could be confusing. So important to just kind of recognize that, here in this notation you do x first and then you do y. So the partial derivative with respect to x we had found to be, I'm going to do that. We found that to be 15x squared y squared, and now we do the partial derivative of that with respect to y. So we'd have 15x squared times 2y, we'd have 30x squared y. Okay? Whereas on this one, we start with the derivative of f with respect to y, which we found out was 10x cubed y, and now we find the derivative of that with respect to x, which would be 30x squared y. You'll notice they are the same. They won't always be the same, but they are the same in this case. So it's not that it's that hard, but you do have to recognize this notation, that in this kind of Euler notation, we just go in order. Do this one, then this one, x then y, and over here y then x. But in Leibniz notation, it looks more like this, and this means that you did x first, and then you did y. You do y first and then you do x, because it comes from this idea that you do a derivative and then you take the derivative of that derivative.